Ladies and gentlemen, my name is Frank Zhong, Deputy Director General of the World Steel Association. It's my pleasure to speak here. I wanted to join the conference in person, but unfortunately I was not able to catch up my flight. I hope in the next conference I can see you all in person. I'm asked to talk about the low carbon transition of the global steel industry, but first of all, let me give you a brief introduction of the World Steel Association. We represent steel producers, national and regional associations, as well as some steel research institutes. Our member companies, including steel producers, national and regional associations, account for roughly 85% of the global steel production. Our head office is in Brussels, Belgium. We have also a second office in Beijing, China. We are a non-profit organization. This slide shows that Asia has been playing a leading role in global steel industry, especially in terms of steel production. You can see so far, Asian countries account for roughly 70% of the global steel production as well as consumption. Among Asian countries, China, India, Asia are the major growth drivers for the past two to 3 decades. And from the chart on your right-hand side, you can see the index steel production suggests Asia has started to accelerate from 2016 because of some new investment into the steel projects in the region from outside Asia. How about the outlook of the global steel demand? According to IEA, International Energy Agency's projection, global steel production will continue to grow, but the growth is expected to be slower than the past 2 to 3 decades. This is mainly because of the low carbon transition. So there are basically two scenarios. In the BSU, business as usual scenario, the steel demand is expected to increase to 2,550 million tons by the year of 2050. However, such a strong growth is not aligned with the Paris Agreement. To make sure the Paris Agreement, the goal of the Paris Agreement is achieved, the global steel production as well as steel demand should be reduced from 2,550 million tons to 2,050 million tons, which means the global steel demand will be squeezed by roughly 500 million tons by the low carbon transition. So with the low carbon transition, the global steel demand will grow, but it will be not as much as we expected before. And India, Asia are the new growth drivers in terms of steel demand. This diagram shows the structure of global steel demand additions region by region. You can see in 1900 to 1950, the US and Europe were the largest demand drivers. They represented roughly 75% of the global steel addition. However, in the 1950 to 1973, you can see because of the post-war reconstruction, the European region, the former Soviet Union, and Japan contributed roughly 80% of the additional global steel demand. And over the past 30 years, from between 1990 to 2020, China was the largest contributor. Because China contributed roughly 90% of the global steel demand over the past 30 years. However, in the future, according to my personal projection, I think that in the following 13 years, steel demand in some regions like China, Korea, Japan, EU will decline slightly, while in the meantime, there's going to be strong demand from India and Asia, and I think India and Asia together are expected to contribute roughly 90% of the additional global steel demand in the next 15 years. And steel is a major source of CO2 emissions. Steel accounts for roughly 80% of global direct energy consumption And the emissions also account for roughly 7% of the global total CO2 emissions. And among all of these coal-using industry sectors, steel is the largest. You can see from the chart on your right-hand side, steel is the largest one, followed by cement and chemicals. For steel, roughly 70% of our energy is directly or indirectly from coal. And the decarbonization of the steel industry is required. You can see in the 2-degree Celsius scenario, global steel industry CO2 emissions should be reduced by 55% by 2050. However, in the 1.5-degree Celsius scenario, emissions from the steel industry will need to be reduced by 90% by the year of 2050. So it's very hard. It's a big challenge for the global steel industry. And how steel is responding to the request responding to the call for decarbonization. And the steel industry, we have always been improving our impact on the environment through our focus on water quality, emissions, and dust to air from production of steel. And also we are preparing to address the carbon challenges. As a product or as a material, steel is still less CO2 intensive than most of the competitors' materials for similar applications, for instance, aluminum, carbon fiber, plastics, etc. And steel will continue its role in maintaining a sustainable society. So far, there is no existing technology to produce steel products with no CO2 emissions, but the development of new breakthrough technologies will take some time, but the R&D is being done in many places around the world, especially in Europe and Asia. As a Global Steel Association, World Steel, we have prepared many policy papers to demonstrate or to showcase what the steel industry is doing, what we are going to plan to do. If you are interested in our policy makers policy papers, you can download from our website free of charge. This is about our pathway to carbon neutrality by 2050. We have identified 3 major pathways for steel industry's decarbonization. From this diagram, you can see that there's going to be a slight increase in steel demand in 2050 as compared to the demand in 2020. However, we believe we can still achieve carbon neutrality by 2050 with these 3 major pathways. The first one being efficiency improvement. Second one is the increased use of scrap. Third one is introduction of breakthrough technologies. Let me explain these 3 pathways one by one. Path 1 is our step-up program. This is a new industry-wide efficiency improvement program, which was launched by the World Steel Association in 2019. So far, we have engaged more than 20 production sites around the world. We introduced the best practices in terms of CO2 emission from those leading players to those selected production sites, so they can improve their CO2 efficiency. And we aim to improve energy efficiency focus on 4 levers, which is shown in the diagram. We focus on raw materials quality improvement. We also improve the energy efficiency of the production sites. We also improve the process reliability, also the process yield of the steel making plants. And according to our evaluation, there is going to be a potential to reduce CO2 emissions by up to 20% for iron ore-based steel plants. So if we introduce the best practices into those iron ore-based steel plants, globally, the CO2 emissions can be reduced by 20% for those high CO2 intensive steel plants. Path 2 is to maximize the use of steel scrap. And according to our evaluation, to use 1 ton of scrap, we can reduce or we can avoid 1.5 tons of CO2 emissions. And according to our modeling work, we believe that the global end-of-life scrap availability will be more than doubled by 2050 as compared to the number in 2020. In 2020, the end-of-life scrap availability was roughly 390 million tons, and this number may go up to 900 million tons by 2050, so more than doubled. And the scrap-based EAF route is becoming a preferred option in most regions, including China. But in Asian countries, I think this scrap-based EAF technology is still not preferred. They prefer iron ore-based route. And we expect an increasing use of electric arc furnaces and steel scrap in the global steel industry. According to IEA's projection, blast furnaces, BF blast furnace and BOF share should decrease from currently 90% in 2019 to 30% in year 2050 in terms of steel capacity mix. So, but 2019, roughly 70% of global steel capacity are blast furnace based, and by 2050, smelting reduction, blast furnace and CCUS route should increase its share to roughly 10% from currently 0. So far there is no smelting reduction, followed by blast furnace and CCUS route. This segment is going to be developed in the coming years, and the share of scrap-based EAF should rise to 38% in 2050 from currently 22%, and hydrogen-based DRI followed by EAF should rise to 8%, and currently the share is 0. There is going to be a change in energy mix of the steel industry. According to IEA's scenario, the coal share in global energy demand for steel industry will need to decrease from 74% in 2019 to only 52% in 2015. Out of that, 16% will be equipped with the CCUS. So you can see by 2050 we still need coal, and coal will still be more than half of the global energy demand for the steel industry. But in terms of electricity, its share was only 13% in 2019, and this number is going to be 30% in 2050. Out of that, roughly 9% will be used for production of hydrogen, and bioenergy share currently is only 2%, and this number is going to be doubled to roughly 5% by 2050. I think for some regions, this number is a little bit underestimated, especially for Shanghai. For China and Latin America. Then the role of bioenergy can be bigger in the future. This is IEA's scenario for crude production by process by 2050. You can say there is a significant difference in production process. For instance, for example, for EU, they prefer scrap-based EAF, while for North America, they will have both scrap-based EAF and hydrogen-based DRI, followed by EAF. And in terms of China, currently, blast furnace and BOF capacity represent roughly 90% of China's total steel capacity. And then this year is expected to decline to only 35% by 2050, and 100% scrap-based EAF capacity, its share should rise to 50% from currently only 10%. And for smelting reduction, based blast furnace and also hydrogen-based DRI followed by EAF capacity, they should have 8% share respectively. Pass-through is about breakthrough technologies. We have 3 categories. The first category is CCUS. We continue to use carbon as a reductant, but we can prevent the emission of the fossil CO2 by capture by using carbon capture, utilization, and storage. Or we can also use sustainable biomass to replace the energy. And so far, CCU is being widely deployed around the world, especially in Europe and East Asia, especially in some Chinese steelmills have already widely deployed or adopted CCU technologies. Or CCS, carbon capture and storage, is being just started. There is only one real deployment in the global steel industry, which was installed in the UAE owned by the Emirates Steel. These days, there are more and more steel companies are studying if there is a role for CCS to play in their low carbon transition. And biomass are being tested in Europe and then Latin America, and some Latin American players are trying to see if they can export biomass from Latin America to Asia and Europe. So in future, biomass will have bigger role to play. The second category is hydrogen. We can use hydrogen to substitute carbon as a reductant. In this case, the production process will generate water rather than CO2. And that's going to be the most promising technology for the next 10, 20, 30, even 50 years. And in terms of R&D progress, European steelmakers, Asian steelmakers are taking lead. And however, the source of green hydrogen and the cost of the green hydrogen remain a challenge for the global steel industry. The third one is using electrical energy through an electrolysis-based process. This is going to be the future technology for 2060 even onwards, because it's still at the laboratory test phase, and more R&D investments are required for pilot production of this technology, or pilot deployment of this technology. What about the actions of the global steel makers? According to my information, by the end of 2022, more than 30 steel makers globally have announced specific ambitions for their roadmap and targets for decarbonization. These 30 steel makers represent roughly 40% of the global steel production. In other words, 60% of the global steel production has not been covered by clear decarbonization targets. And most of these 30 steelmakers aim to be carbon neutral by 2050 and plan to reduce their CO2 emissions by 30% by the year of 2030. The European steelmakers SSAB and Liberty Group, they plan to be carbon neutral by 2030, which means in 7 years, these two companies will become net zero in their steelmaking plants. There are some first movers in terms of low carbon transition or decarbonization. For instance, SSAB, the Swedish steel company, is the first steelmaker that announced to supply fossil-free steels to the market by 2026. And ArcelorMittal has delivered its first automobile panels manufactured using 100% renewable energies and 100% scrap-based EAF since March 2022. In China, the leading players, China Baowu Steel Group, HBS Group, they are also progressing very well. They are both building large-scale H2 hydrogen-based DRI capacities. The HBS capacity was completed by the end of 2022. Now they are testing the operation. The Baowu facility is being built, which will be put into the first production by the end of this year. These two companies, their hydrogen-based DRI capacity have roughly 2 million tons per year. In the meantime, there are also some startups In Sweden, USA, France, and Spain, for instance, there is a green H2 green steel in Sweden. In USA, there is a very well-known Boston Metal. In France, in Spain, there are also two or three new startups. They have not produced anything, but once they will produce only zero emission, zero carbon steel. And all of them are expecting to put their first production by the year of 2028 or 2030. There are some challenges for the Asian steel industry, as I mentioned earlier. By September 2017, all Asian countries have ratified the Paris Agreement. And as said in the previous slide, there is going to be strong potential for steel demand in Asian countries. Currently, Asian 10 countries, they consume steel products about 8 million tons, 80 million tons a year. And this demand is going to be more than doubled in the next 15 years. According to our projection, Asia's total steel demand may reach 160, even 180 million tons by the year of 2035. In the meantime, there are also some faster growing capacity to be installed in Asian countries, in particularly in Indonesia, Vietnam, and Malaysia. The existing capacity crude steel making capacity in Asia is about 90 million tons per year, and this capacity also may be doubled in the next 7 years, which means by 2030, the Asia's total crude steel making capacity may reach 140, 150, even 170 million tons if all of those uncertain projects are implemented. It's worth noting that most new steel capacity to be installed or to be built in Asia are fossil fuel based or are coal based, which means very high CO2 emission intensity of this new steel capacity installed in Asia. Of course, it's additional demand for coal. And most steel makers in Asia are not responding very actively to the decarbonization request. As everybody knows, that the European Union is introduced so-called CBAM, and its impact is going to be observed. But I believe that the CBAM will push the global steel industry, especially in the steel makers in East Asia, like China, Japan, Korea, also in Southeast Asia, as well as the steel makers in India, to push forward their decarbonization efforts. So just to summary, Asian countries remain a hub for global steel production as well as steel consumption. They represent 70% so far, and the share may increase because of the rising share of India and Southeast Asia. So the Asia's share in global steel production and consumption will continue to grow. And this global steel industry is progressing very well in terms of decarbonization, and with European steelmakers and Asian steelmakers taking lead. Most Asian steelmakers need to be more active in low carbon transition, and the Asian steel industry face huge challenges on the way to carbon neutrality because of the huge potential steel demand, as well as the massive new capacity being built in the region, and then most of the new capacities are fossil fuel based and also high CO2 emission intensity. So this concludes my presentation. Thank you so much. If you have any questions or have questions or comments, please feel free to send them to me by email. Thank you.